In this, the third week of basic science, we're going to start talking about the states of matter and some basic concepts around the states of matter. First of all, we have to introduce you to something known as the kinetic theory of matter. The kinetic theory of matter is an explanation of how matter works, if you will, and why matter does what it does and how it does what it does. First of all, it states that all matter is made up of extremely small particles known as atoms. This is called the atomic theory of matter. So all matter is made up of these small particles, and initially it was thought that these small particles or atoms were indivisible, but as it turns out, that didn't turn out to be the truth. The kinetic theory of matter states that all the molecules or atoms that are in matter are in constant motion. And this constant motion is the reason for some of the properties we find within matter. And the higher the temperature, the faster the motion of these particles. Cohesion, which is a force that occurs, is the attraction that holds together atoms or molecules of the same type. And so if you have a salt molecule and another salt molecule, they will be attracted to each other, and that force of attraction is known as cohesion. The faster the molecules are moving, the less cohesion affects them. Kinetic theory is a theory that helps to explain the differences between the states of matter, that is, between gas versus liquid versus solid. And we'll talk about that some more in future slides. So here we have the three fundamental states of matter. If you look it up on Google, they'll actually talk about 5 or maybe even 6 states of matter, but these three encompass 99.999% of all matter that you will encounter. The first of these is the solid. The solid is composed of molecules that are fixed in 3 dimensions. That is, they're bonded together to each other in 3 dimensions. And because of that, a solid has a defined or fixed shape as well as a defined or fixed volume. Now, even in this fixed shape and volume, these molecules still have some degree of motion or vibration. And this motion or vibration can transmit energy to other aspects of matter. The liquid is when the molecules are fixed in a single dimension. So there is a fixed volume but not shape. Now in this situation, the matter takes the shape of the container that it's in and forms a horizontal surface. And at that point, the volume is fixed. The last of these is the gas, where the molecules are not fixed, but in all 3 of these states, there is still motion going on. It's just that the degree of freedom involved is much less in a solid compared to a gas. These 2 maps show something called Brownian motion. Brownian motion is the random motion exhibited by microscopic particles. This was first observed when a pollen particle was put on a slide with water and then observed under the microscope. On the right here, you can see that when you contain these particles in an enclosed space, they tend to slam into the sides of the space. And we will be talking in the future about something known as pressure. And this slamming of molecules against the side of the space is what is responsible for what we measure as pressure. Another phenomenon that occurs naturally because of the kinetic theory of matter is something called diffusion. Diffusion is the movement of one set of molecules from a high concentration to a low concentration. And what you can see in the diagram here is on the left you have a high concentration of particles. On the right there's a low concentration of particles. And diffusion causes these particles to move from left to right naturally. And this is caused by what is termed here the concentration gradient. That is the difference in concentration over this space. dc represents the difference in concentration. dx represents the point in space from left to right on the x-axis, if you will. Another phenomenon that occurs because of the kinetic theory is something known as osmosis. And osmosis is similar to, but not the same as, diffusion, in that osmosis is a passive phenomenon, which means it occurs without the input of energy, but it involves some technicalities that don't occur with diffusion. Now, osmosis is defined as the one-way motion of molecules through a semi-permeable membrane. Now, what you have in the diagram here is a container that's divided in half by a selectively permeable membrane. And what that means is that membrane is permeable to the water molecules represented by little blue circles, but not permeable to the sugar molecules represented by the green circles. And what happens is that the green circles can't move. And so osmosis causes water molecules to move from the left to the right. And the osmotic pressure, you'll hear people talking about osmotic pressure, and osmotic pressure is simply the force that drives or is responsible for the movement of particles from the left, water particles from the left to the right, through the semi-permeable membrane. Now, osmosis and diffusion have some things that are common and some things that are not in common. A Venn diagram is a diagram where you draw two circles that overlap. And where the two circles overlap are where the two phenomena have things in common, and where they do not overlap is where the aspects are specific for that phenomenon. So for example, on the left here, diffusion, the aspects of diffusion that only pertain to diffusion is that the solvent and the solute particles move to equalize concentration, and that there's no semi-permeable membrane involved. On the right, the aspects of osmosis that are specific to osmosis is that only solvent molecules move. The solute particles do not move because of the semi-permeable membrane, and the movement is through a semi-permeable membrane. The central area is the aspect of these two phenomena that are the same, and that is there's an attempt to equalize the concentration of the two solutions. And this occurs, this is always happening, and it's the hope that there's an equalization of concentration anytime you have either of these going on. Now, when we talk about solids, there are essentially two types of solids. There are crystalline solids and there are amorphous solids. A crystalline solid is characterized by atoms or molecules that are in a well-organized arrangement or lattice structure. These crystalline substances have a well-defined melting point, and if you look on the left here, you can see that a crystalline solid has a nicely organized particles that are all arrayed together. And when you look at the example, table salt, you see that if you looked at those smaller pieces, they would be very nice little square pieces. And when you measure the melting point of salt, it's a very specific temperature. Amorphous solids, on the other hand, are when the molecules or atoms are poorly organized, which is shown on the right here. And the overall shape of the solid is much less well organized. And when you look at the melting point, it actually varies across a range of temperatures instead of a specific well-defined temperature. Now, the properties of solids are as follows. First of all, they have a possibility of deformation, or they can be deformed. And deformation is a change in shape of the solid when a force moves the molecules that are normally stationary. So any time, I mean, one way to think about it is if you have a block of metal or of some other solid and you make a dent in that block, what you've done is moved the molecules in that solid, and those molecules don't normally move. And the interesting thing is that once they're deformed or once a deformation occurs, it does not spring back to what it was before. Another is the idea of elasticity. Solids have some ability to return to their original shape after undergoing deformation. And I just said in some solids, this doesn't return. Other solids, this does return. And if it has that capability, then it has increasing elasticity. For example, if you dent a car, which is a solid part of a car, then there's very little elasticity there, and that dent remains. But on the other hand, if you dent some type of rubber, or let's say a rubber ball, then it will return to its original form because it has higher elasticity. Plasticity, on the other hand, is the maximum amount of deformation that a solid can undergo without breaking, without actually pulling apart. So, for example, if you take say a plastic spoon and you bend it, you're causing deformity, and it has some degree of elasticity, so it will return to normal if you let go. But if you bend it to a certain point, it will then break. And how far you can bend it before it breaks is what is known as plasticity. And then hardness is the resistance of a material to small deformations. So the harder a material it is, the more force required to cause any deformation whatsoever. And hardness can actually be measured in a couple of ways. The left here shows something called the Mohs hardness scale. And the Mohs hardness scale ranks the hardness of any particular substance to other materials. And you'll notice at the top of the table, you may or may not be able to read this, but it's diamond. And diamond's considered the hardest solid that there is. At the bottom is talc, and talc is a very powdery or not very hard substance. And you can see that various substances are labeled on this scale. And you can see on the in the right column of the table other substances that have been put in to show that they're where they fit in this hardness scale. Now, another hardness scale is called the Brinell scale of hardness. And this scale is based on how easy it is for a material to be dented by a standard hard ball that's applied to the substance. And so what they do is they take this ball and they drop it or apply it and then look at the size of the indentation that's caused by it. And then that is a standard for measuring the hardness of any particular substance. Now, deformation, there are various types of deformation depending on the relationship of the force to the surface and to the molecules in the solid. So, for example, if you try to pull the molecules of a solid apart, that deformation is called a stretching motion. So if you grab two ends of a plastic spoon and try to separate your hands, you're trying to stretch the molecules in that solid, and you'll realize very quickly that that's difficult to do. And plastic is not particularly stretchy. Compression, on the other hand, is doing the opposite. Instead of trying to pull the molecules apart, you try to push them together. And you'll find that for many substances, you can pull apart substances that are very, very difficult to push together because molecules in a solid are already packed fairly closely together. And to try to force them into a closer relationship to each other is virtually impossible. Bending is the combination of stretching and compression, where one side of the object is compressed and the other side is stretched. If you bend a plastic spoon again, you're stretching the side that is, let's say you bend it towards you, the two ends towards you. You're stretching the side that's away from you and you're compressing the side that's toward you. And then Shear is when the forces are not necessarily perpendicular to the axis of the solid. So that's stretching instead of pulling or pushing, which are both perpendicular to the axis of the solid, it's at some other angle other than pulling or pushing, and that's known as shear force. And then the last of these is called torsion, and that's when you do a shear force, but it's a circular movement in an attempt to form the solid. We will stop at this point and resume the lecture on the next video.